Welcome to our special report on a groundbreaking solar event. We humans tend to think of the sun as this unchanging, ever-reliable ball of fire in the sky. But the reality is far more dynamic, far more powerful, and frankly, far more awesome. Today we dive into the fascinating details of a major piece of the sun breaking off. It's a cosmic event that has scientists buzzing and has captured the imagination of space enthusiasts worldwide. Let's explore what happened, why it happened, and what it means for us here on Earth.
So, picture this, February 2nd, 2023. It's a day like any other, or so it seems. The world is going about its usual business, unaware of the extraordinary event about to unfold in the cosmos. Astronomers are going about their usual business, telescopes trained on the sun, meticulously observing its every move. These scientists, dedicated to understanding our closest star, are always on the lookout for solar flares, sunspots, and other solar phenomena. When suddenly they see it, a massive filament of solar material, a prominence as we call it, lifting off from the sun's surface. This isn't just any prominence, it's colossal, stretching out like a giant arm reaching into space. Now, prominences themselves aren't that unusual. They are relatively common solar events, occurring when loops of plasma are ejected from the sun's surface, held in place by magnetic fields. They're these giant arcs of plasma held in place by the sun's magnetic field. These magnetic fields are incredibly strong, capable of holding vast amounts of solar material in a delicate balance, but this one was different. It was unlike anything the astronomers had seen before. The prominence wasn't just looping back to the sun's surface, it was behaving in a way that defied expectations. It wasn't just erupting outwards, it was breaking away, separating from the sun entirely. This was a rare and extraordinary event, something that had the potential to change our understanding of solar dynamics. This wasn't just a solar flare, this was a piece of the sun itself, embarking on a journey through the solar system. Imagine a fragment of our star, traveling through the vast expanse of space, carrying with it the secrets of the sun's inner workings. It was a sight to behold, captured in stunning detail by NASA's Solar Dynamics Observatory. The observatory's instruments recorded every moment, providing us with invaluable data and breathtaking images of this unprecedented event. This was a day that would go down in the annals of solar observation, a day when we witnessed the sun in a way we never had before.
Now you might be wondering, what could possibly cause a piece of the sun to just break off? It's a fascinating and somewhat alarming phenomenon that has intrigued scientists and space enthusiasts alike. The sun, our closest star, is a dynamic and ever-changing entity, constantly in a state of flux. But what exactly triggers such dramatic events on its surface? Well, the answer lies in the sun's incredibly powerful and complex magnetic fields. These magnetic fields are not static. They are in a constant state of motion and change. The sun's magnetic field is generated by the movement of electrically charged gases within its interior, a process known as the solar dynamo. This dynamo effect creates a magnetic field that extends far out into space, influencing the entire solar system. Think of the sun as a giant ball of churning electrically charged gas, constantly generating these invisible magnetic fields. The sun's surface, or photosphere, is a seething mass of hot plasma, with temperatures reaching up to 5,500 degrees Celsius. This plasma is in constant motion, driven by the intense heat and pressure from the sun's core. As the plasma moves, it drags the magnetic field lines with it, causing them to twist and turn. These fields are like highways for the sun's plasma, guiding its movement and shaping its activity. The magnetic field lines can become highly twisted and tangled due to the differential rotation of the sun, where different parts of the sun rotate at different speeds. This twisting and tangling can store a tremendous amount of energy within the magnetic fields. Sometimes these magnetic field lines get so twisted and tangled, like a rubber band stretched too far, that they snap and realign. This process is known as magnetic reconnection. When magnetic reconnection occurs, it releases a vast amount of energy in the form of heat, light, and kinetic energy. This energy can accelerate particles to near the speed of light and create powerful solar flares and coronal mass ejections. And when they do, they release an incredible amount of energy, launching massive amounts of solar material into space. These eruptions can hurl billions of tons of plasma and magnetic field into space at speeds of up to several million kilometers per hour. The material ejected during these events can travel vast distances, sometimes reaching Earth and affecting our planet's magnetic field and atmosphere. That's what we call a coronal mass ejection, or CME. CMEs are among the most powerful and disruptive solar phenomena. They can cause geomagnetic storms that disrupt satellite communications, power grids, and even pose a risk to astronauts in space. Understanding CMEs is crucial for predicting and mitigating their impacts on our technology-dependent society. And in this case, the CME was so powerful, it actually broke off a chunk of the sun's prominence. Solar prominences are large, bright features extending outward from the sun's surface, often in a loop shape. They are anchored to the sun's surface in the photosphere and extend outwards into the solar corona. When a CME occurs, the immense energy released can tear these prominences away from the sun, sending them hurtling into space. This dramatic event is a testament to the incredible power and complexity of our sun's magnetic field.
So, a piece of the sun breaks off, hurtling through space. This isn't just any ordinary event, it's a solar prominence eruption, a spectacular display of the sun's power and energy. Imagine a massive loop of plasma, millions of miles long, suddenly snapping and sending a chunk of itself into the cosmos. Naturally, the next question is, should we be worried? People often wonder if such a dramatic event could have dire consequences for us here on Earth. It's a valid concern, given the sheer scale of these solar phenomena. Could this cosmic debris come crashing into Earth, wreaking havoc on our planet? The idea of a piece of the sun colliding with Earth sounds like the plot of a sci-fi disaster movie, but let's delve deeper into the science behind it. Well, the short answer is, not really. Scientists and space experts reassure us that the likelihood of such an event causing direct harm to Earth is extremely low. But why is that the case? You see, space is really big. The distances involved are almost incomprehensible. Even though this solar prominence was massive by our standards, it was still tiny compared to the vastness of space. The universe is a vast expanse, and the odds of a small piece of solar material hitting our planet are minuscule. And even though this solar prominence was massive by our standards, it was still tiny compared to the vastness of space. The sun itself is just one star among billions in our galaxy, and our galaxy is just one among billions in the universe. The scale is mind-boggling. The chances of it hitting Earth directly are astronomically small. It's like trying to hit a tiny target with a dart from miles away. The vast distances and the relative sizes involved make such an event highly improbable. But that doesn't mean we're completely off the hook. While a direct hit is unlikely, there are other ways these solar events can affect us. Solar prominences and coronal mass ejections, CMEs, can still have significant impacts on our planet. When these CMEs, even the ones that don't involve a chunk of the sun breaking off, interact with Earth's magnetic field, they can trigger what we call geomagnetic storms. These storms can disrupt satellite communications, affect power grids, and even create stunning auroras in the sky. So while we may not need to worry about a piece of the sun crashing into us, we should still be mindful of the other ways our star can influence life on Earth.
Now, this isn't the first time the sun has thrown a cosmic tantrum. In fact, our star has a bit of a history of these dramatic events. One of the most famous examples is the Carrington event of 1859. Back then, a massive solar storm, even bigger than the one we're talking about today, slammed into Earth. It caused telegraph systems to go haywire, with some operators reporting sparks flying from their equipment. And get this, the aurora borealis, the northern lights, were visible as far south as Cuba. It was a spectacular display of the sun's power, but it also highlighted our vulnerability to these solar outbursts.
Thank you for joining us on this journey through one of the most intriguing solar events in recent history. It's a reminder that the universe is full of surprises and that there's always something new to discover. Stay tuned for more updates and in-depth analyses on cosmic phenomena. And remember, when it comes to the universe, keep looking up and keep asking questions.